Hi everyone, welcome back to the channel. Today we're diving into an important concept in computer architecture, instruction code. If you're curious about how computers understand and execute tasks, this video is for you. By the end, you'll clearly understand what instruction code is, how it works, and how operations like addition or subtraction are encoded. Let's get started. First, what exactly is an instruction code? Simply put, an instruction code is a binary code that specifies a sequence of microoperations for the computer. In other words, it's the language a computer understands to execute tasks. Here's what happens. Instruction codes along with data are stored in memory. The computer reads each instruction from memory and places it into something called a control register. The control unit then interprets the binary instruction code and performs the task step by step by issuing a sequence of microoperations. Now let's break down the structure of an instruction code. It mainly has two parts, the operation code and the operand. Now let's discuss them one by one. First, the operation code, often called the opcode, is a group of bits that define the operation the computer needs to perform. For example, operations could include add, subtract, multiply, or any other function the computer can execute. The number of bits required for the opcode depends on the total number of operations available on the computer. Here's an important rule. To represent 2 to the power n distinct operations, you need at least n bits. For example, if a computer supports 64 distinct operations, how many bits do we need for the opcode? That's right. Since 2 to the power 6 equals to 64, so we need 6 bits for the operation code. Another part of the instruction code is the operand. While the opcode tells the computer what operation to perform, the operation tells it where or on what data to perform the operation. For example, if the instruction says add 5 to register A, the opcode specifies the add operation and the operand points to the register A and the value 5. We'll make it more clear with an example. Suppose we have this instruction 1101010011. Here's what it means. The first part 110101 is the opcode for add, and the second part 0011 is the operand referring to register A. Now the computer executes the add operation on the data stored in register A. We'll take another example. If we have 1010010100, the opcode 101001 could mean subtract. The operand 0100 could refer to a specific memory location. So, to quickly recap, an instruction code is a binary code that directs the computer to perform specific operations. It is two parts, opcode, which specifies the operation like add or subtract, and operand, which specify the data or location to work on. The number of bits in opcode depends on the total number of operations available. For example, 6 bits can represent 64 distinct operations. Understanding instruction code is a fundamental to how computers work at the core level, and I hope this video gave you a clear explanation of that. If you enjoyed learning about instruction codes in computer architecture, don't forget to hit the like button and subscribe to the channel for more tech tutorials. Drop any questions in the comments below and I'll see you in the next video. Take care and happy learning.